Another place that you'll see dew point plotted is on sounding graphs. In this case, it's on a STU-V diagram. A STU-V diagram basically plots temperature and dew point temperature against pressure, which increases decreases as you go up. Temperature increases here as you go to the right. On the right-hand side of these graphs, you usually have temperature plotted. You know it's on the right-hand side of the graph because temperature is always larger than dew point, and the numbers of temperature are warmer on the right part of the graph than they are on the left. So the line on the right, to the right of the graph here, going up along here, represents temperature, whereas the line that sort of winds up to and fro on the left side of the chart here generally represents dew point temperature. So we begin to interpret the graph from the ground up. Each of these soundings tells a story of the atmosphere, of where the warm and cold air is, and also where the humid and dry air is. In general, you expect the temperature and dew point to decrease as you go further from the surface of the Earth, because you get further from the source of warmth on the surface of the Earth, and also further from the source of humidity, which is generally the oceans and the surface of the Earth. So we start at the surface over here, at this point over here, and we notice that the dew point and temperature meet at this point. And if you go down all the way here to this point here, between 0 and -10, if you look very carefully, there's an extra -5 line there. You'll see that the line comes out closer to the -5, so that you have approximately -4 degrees Celsius, both for the temperature and dew point. You remember that they're touching here so that these values are equal. This indicates that you have a saturated conditions at the surface over here. Because temperatures are below freezing, you expect there to be frost on the ground on a day like this. If this layer where these two curves touch would be a bit thicker, then you would expect there to be fog as well, but in this case that doesn't appear to be the case. If you go up 150 millibars, which is up about a mile or 1.5 kilometers, you'll notice that the dew point over here on the left and the temperature curve on the right have actually gone further apart. So we're going to take separate measurements here. You'll notice here if we go further down over here, we end up very close to the 0, so it's around -2 Celsius. And if we follow the dew point line down, we'll actually notice that it's quite a bit colder here, indicating a much drier atmosphere, less humidity in the air. You get a value of around -32. So that indicates that this is a very dry layer of the atmosphere over here. So if you climb Mount Washington on the day like this, you'd find that that things get considerably less humid as you go up the mountain. Finally, we look at 650 millibars, which is this line here between 600 and 700. And we look at that where that intersects with the temperature and dew point curve. Again, always keep in mind that the dew point curve is on the left and the temperature is on the right. So that dew point will always give you a lower value than temperature. Okay, so in this case, if you follow these lines down to the bottom over here, you see that they're relatively close to -10. And that the pressure, that the temperature, is -11 degrees Celsius, and that the dew point is -12 degrees Celsius. So in this layer, they're very close together, and you can probably presume that there's some sort of cloud in this layer. So if we go from the bottom up in this graph, we start at the surface with a saturated layer, indicating that there's frost because temperatures are also below 0. You go up about a mile to 850 millibars, which is about the top of Mount Washington. You see that it's very dry. Okay, the dew point goes all the way down to -32 degrees Celsius. So a cold dew point indicates a dry atmosphere with less humidity in it. Finally, you go up here where the dew point and temperature have gotten close together. And you can actually expect that in this whole layer here, where the temperature and dew point is close together, that you will have some scattered cloud. Okay, it often turns out that when there's scattered cloud, you don't know whether the weather balloon is going to go directly through the cloud or not. Okay, so these areas probably represent a cloud layer of scattered cloud, where uh, atmospheric humidity or the relative humidity is relatively high.